at this visualization. This is called as a bar plot, or if I slightly tweak it, it turns out to become a visualization called as histogram. But before that, let us understand what is probability distribution. And this is pivotal because we have a specific visualization in Tableau called as histogram, right? So what is probability in the first place? Probability is nothing but long run average of a random event occurring. It's different from your subjective beliefs. Now let us understand these things using a lot of additional examples, right? Okay, in the next slide, I'm going to explain a little bit more about the probability, etc. But until then, please hold on to your horses. A probability distribution is a rule that identifies possible outcomes of a random variable and assigns a probability to each value. For example, if it is probability of getting ahead, if you flip a coin once, there's a probability associated with it. And this is a random variable. Head is a random variable. If the output data of interest that you're dealing with is discrete, then it's called as discrete probability distribution. If the output variable that you're trying to deal with, or the event that you're dealing with, is continuous in nature, it is called as continuous probability distribution. For example, if you're trying to check the probability of heights of the students, right? Say there are 100 students in a classroom, and if you randomly pick one person, what is the probability that the person's height would be 6 feet? There's a probability associated with it. But when you deal with this event called as height, it is continuous variable. Hence, the underlying probability would be called as continuous probability distribution. Whereas, if you're looking into whether the output is going to be a head or a tail, then you have only finite number of values possible, and those finite values are either a head or a tail. These two are discrete events. Hence, the underlying probability distribution would be called as discrete probability distribution. Now, continuous distributions are always nicer to deal with. And most often than not, if you have large number of possible values or large number of events, if instead of head and tail, if I have, say, a million other discrete events which are possible, in that case, your discrete probability distribution would appear as if it is continuous probability distribution. Right? If you have not understood this, don't worry, don't press your panic button. The next slide will clearly explain you all about that. Let us understand this. I'm assuming that you all are aware of playing cards and you all are aware of the fair deck. A fair deck of playing cards would contain 4 variants, which is diamond, red colored heart, and then you have club and spade. This is a spade and this is a club. And each of these variants would have 13 cards. For example, if you look at this um, club, you have A, which is equivalent to 1. We have 2, 3, 4, 5, 6, 7, 8, 9, 10. J is equivalent to 11, Q is equivalent to 12, K is equivalent to 13. Right? So each variant has 13 cards, 13 in each variant, and you have 4 such variants. So the total number of cards would be equivalent to 52. And you have 4 A's. If you look into A, you have 4 A's in entire 52. you will have four cards with a number 2. You will have four cards with a number 3. You'll have four cards with a number 4, so on and so forth. Suppose you randomly picked a card from the card deck. You have randomly picked a card, assume. What is the probability that this card will be bigger than 10? So how many cards would you have which would be bigger than 10? If you look at this, bigger than 10 is nothing but greater than 10, and greater than 10 you have only three cards. One is J, one is Q, and one is K. How many variants of J do you have? 1, 2, 3, and 4. So we have four variants of J. How many variants of Q do we have? 1, 2, 3, and 4. How many variants of K do we have? 1, 2, 3, and 4. How do we calculate the probability? Probability of a card being bigger than 10 is equal to total possible events, which is 4 plus 4 plus 4. It can be one of these J cards, one of these Q cards, or one of these K cards. So the summation would be 12 out of total number of cards, which is 52. Now let us try to solve this. What is the probability that a card would be equal to or bigger than 10? So greater than or equal to 10. How many cards do we have? You'll have card 10, and bigger than 10 would be J, Q, and K. And each card has four variants. So you have four variants of 10, four variants of J, four variants of Q, and four variants of K. If I look into the total number of possible events, the summation is 16 out of total 52 cards. Now, let me look into the probability that a card will be smaller than 3. So I'm speaking about less than 3. Less than 3, we have only two cards. We have A and we have 2. We have four variants of A and we have four variants of 2. So the probability of a card smaller than 3, if I randomly pick one card out of these 52 cards, is equal to 4 plus 4, which is 8, divided by total number of cards. Now let us try to solve the last one, post which I'll actually explain you about histogram and probability distribution. The probability of a card, if you randomly pick it from one of these 52, being greater than 4 and less than 8 is a question. Greater than 4 or less than 8, you'll have numbers which includes 5, 6, and 7. We have four variants of 5, sorry. We have four variants of 6, and we have four variants of 7. So the probability of a card, if it's randomly picked from the fair deck of playing cards, and the probability being greater than 4 and less than 8 is equal to total number of possible events, which is 12, out of total cards, which is 12 by 52. All right. Now let us spend some more time and try to understand this probability distribution. So look at this table. The daily sales of large flat panel televisions at a store X is provided. Probability of selling 0 television sets on any given day is 0.4 or 40%. Probability of selling 1 television set is equal to 0.25. Probability of selling 2 television sets is 0.2. Probability of selling 3 television sets is 0.05, and probability of selling 4 television sets is 0.1. If I represent the number of television sets sold on the x-axis and the probability on the y-axis. And if each of the probabilities is represented using a bar, for example, selling 0 television sets is 40%, represented using 1 bar. Probability of selling 1 television set is 0.25. Probability of selling 2 television sets is this bar, which is 0.2, so on and so forth. This kind of a representation is called as probability distribution. Probability on the y-axis, event on the x-axis. Simple. And if you're trying to plot number of television sets sold on the x-axis, which is discrete in nature, number of television sets sold can be 1 or 2. It can never be 1.5. Remember, if you can represent something in a decimal format, it is continuous data. If you can represent something in a whole number format, or if you cannot represent something in a decimal format, it would be called as discrete data. If you're plotting discrete data on the x-axis, it will be called as what? Discrete probability distribution. Instead, if I plot the heights of people is continuous, hence it would be called as continuous probability distribution. Okay, now let us try to solve this and then let us move on further. What is the probability of a sale? Probability of a sale meaning if I sell greater than 0 television sets, that is if I sell at least 1 television set, that is called as a sale. I'm selling something. What are those possible events? Given this table as a reference, 1, 2, 3, or 4. These are the possible events wherein you have a probability of sale. And since the probability values are already here, we just need to add all of these numbers. And if I add all of these numbers, the total would be 0.6. Now, if I ask you this question on what is the probability of selling at least 3 television sets, this is what I say. Probability of selling greater than or equal to 3 television sets, which is equal to probability of selling 3 television sets plus probability of selling 4 television sets. Probability of selling 3 television sets is given in the table as 0.05 here. And probability of selling 4 television sets is given as 0.1 here. And if we add these two, you get 0.15. And this is the probability of selling at least 3 television sets. So now I'm assuming that you're clear about how to calculate probability given an event. You know how to represent a bar plot with probability on the x-axis and event on the probability of an event occurring on the y-axis and an event occurring on the x-axis. Right? If you represent in this way, it's called as probability distribution.